Hello, I'm Mike.
And I'm Nick. This is our ME 191 final project for Milwaukee School of Engineering.
For our final project, we created a digital weight and distribution scale utilizing an Arduino. This project is essentially a 1/10 size version of a scale that would be used for racing applications. The sole function of this device is to not only just measure the weight of the car, but to also determine the weight distributions of the car from front to back and left to right. There are two main portions to this project: the actual scale circled in white and the UID circled in yellow, or the user interface display. The scale uses four force sensors, one on each wheel to gauge the weight of the vehicle. It also uses an infrared sensor to determine if the vehicle has pulled up far enough or not.
The UID is a display board that contains 2 rows of LEDs, a switch, and a pair of red and green LEDs. The row of LEDs signifies the load on the scale from left to right. When overloaded, it will flash red to warn the user that the vehicle is overloading the scale to prevent damage. The switch is used to initialize the weighing process and must be pressed before the vehicle can be driven onto the scale. Lastly, a pair of red and green LEDs are indicator lights for the driver in the car. The indicator will be green and means the driver can keep pulling forward. When the vehicle reaches the correct position, the LED turns from green to red and the weighing begins.
Once the vehicle is centered on the scales, the weighing will begin. Here is another view from the computer. Once weighing has begun, each sensor will take 20 samples. MATLAB will then take each of these samples and average them, and then calculate the weight distributions. If the weight of the vehicle exceeds the limits of the scales, the weight indicators will flash red until the vehicle is removed and the scales reset.
In addition to showing if the scale is overloaded, the LEDs also show the relative amount of weight on each side of the scale.